the famous organometallic compound has a carbon part here, hydrocarbon part here, and some active metal. Basically, the active metal could be magnesium, lithium, copper, variable metals we use. You're going to understand how do you synthesize alcohol from aldehydes and ketones as well as esters here. I start with the very preliminary aldehyde, formaldehyde. To this, we are going to add Grignard reagent. We are going to understand what's going to happen. So basically, let us understand now what is Grignard here. Let us synthesize Grignard. Grignard is basically written as RMgX. This is Grignard. Magnesium is the most liberally used element in synthesizing the Grignard reagent. So I have Rx, to which I treat with magnesium and a dry ether. Usually the ether that we use here is diethyl ether, which can be also written like this, C2H5 O C2H5. The first reaction that's happening here is called as insertion reaction, where the magnesium gets added between the R and X, RMgX. Yes. Here we have synthesized the Grignard reagent. Now let's understand how do I split up the charge here in Grignard. You know, magnesium is a quite electropositive element considered with this R. This R is some carbon chain, any carbon chain it is. So carbon is electronegative when I compare to magnesium. So magnesium is electropositive and this is electronegative. In a simpler way, this is negative and this part is positive here. Now, we are going to understand how does it attack the aldehyde part, RCHO. As we mentioned, this is the carbonyl. The carbon here is electropositive and the oxygen here is electronegative. I treat it with R minus MgX. The reaction type is called as nucleophilic addition reaction. What is the nucleophile here? This R minus that you're seeing right now is the nucleophile because it carries a negative charge. Electron cloud is there. So usually a nucleophile will go and attack the electron deficient center only. Now I can see this carbon is having positive charge. Or do you understand? The nucleophile will attack that carbon. So this nucleophile attacks this carbon. Once the carbon is going to make one more new bond, definitely this double bond should be cleaved. Then only carbon will satisfy its 4-bond policy. H, C, single bond is there, oxygen is there. Since this bond got shifted towards oxygen, the oxygen carries a negative charge. Hydrogen is still there. I have R. Now who else is remaining? MgX is remaining. What charge does it carry? Positive charge. So opposite charge should attract each other. This is negative. So the positive gets attracted here. So this is the intermediate that is getting formed here, followed by water hydrolysis. I treat it in the presence of water. How do you split up the water? H plus and OH minus. Now, as I mentioned, magnesium is a very active metal. Active metals basically have more water affinity. That's what happens. This Mg plus X will get attracted to this OH minus and the H plus will get attracted to the O minus because opposite charges should attract each other. Like CH, OH, H, R plus I am having Mg, right? Mg, OH and X. Let us rewrite it RCH2OH. So you have created a primary alcohol. I take formaldehyde, treat it with Grignard. What I have synthesized is the primary alcohol here.